Hey Stats Class, let's talk about a correlation test and using the line of best fit to find the estimation for a value given that there is a correlation. So the thing I want you to see here is the p-value. Alright, the p-value, we're doing a hypothesis. So basically what the hypothesis test says is the null hypothesis is there is no correlation in this. So they actually use the Greek letter rho here instead of r. So think of this as like r. It's the correlation of the population rather than the correlation of a sample. So we use r for the sample, rho for the population. So the null would say the correlation is 0. And then the alternate hypothesis would say the correlation is, it depends. If there's positive relations, you could say greater than 0. If there's negative, you can say less than 0. But typically we just say it's not equal to 0 to do a two-tailed test. And then if r was positive or negative significantly, then we could find it with the p-value. So the p-value here is 0.010, and we're comparing it to 0.05. So just like in the hypothesis test chapter, the p-value is less than alpha. So that supports the alternate hypothesis, which means there is some kind of non-zero correlation in the population. And what does that mean? Well, that means that this line, that's the line of best fit for the data, is what we would use to estimate values because there is correlation. So the correlation is not 0. If the correlation was not 0, then I would just use the mean for all my estimations, the mean for x, the mean for y, depending on what I'm estimating. But when there is significant correlation, then I'm going to use the line, right? So when the p is less than alpha, right? When the p-value is less than alpha, we're going to use the line of best fit. When the p-value is greater than alpha, you're going to use the means. Okay? Now, the illustration I give to people why this is I tell people to think about height. Okay? The height of people. So this is the shoe size along the x-axis. And then along the y-axis is height. Alright, so as shoe size gets larger, so typically does height. So people that have smaller shoe size typically are shorter. People that have larger shoe size are typically taller. Right? Now, on the line of best fit, so if I draw the line of best fit in here, let's say that it looks like this, okay? One point that's always on the line of best fit is the means. The average shoe size would be on there, and the average height would be on there. So that would be a point on your line of best fit. And so the thing is, if you didn't know any better, you know, if I just said, you know, we're in a room together, okay, so here's the door to that room, and I said, standing outside is a man, and I didn't tell you anything about that man, but there's a man out in the hallway, and he's going to come into our room. So how tall is that man? And that's all I told you. There's just a man out there. You have no idea. So where's your prediction going to go? Your prediction is going to go to the average height. Okay? Your prediction is going to go to the average, the mean, because I didn't give you any more information. Okay? But what if I said the man who is out in the hallway that's going to come into the room has wears a size 18 shoe? Well, now how tall do you think? Do you think he's average height now? No, you think he's taller. Why? Because shoe size and height are correlated. There is a correlation there. So the p-value for shoe size and height would be very small because there is a significant correlation here. It would be significant. So when the p-value is very small like that, it's suggesting a correlation exists. And if a correlation exists, we're not going to use the means. We're going to use the line that describes the relationship. Okay? So that's the idea here. When the p-value is small, it suggests the correlation is significant, which means that the line is the best way to estimate. Okay, now going back to that same illustration. All right, the man out in the hallway that's going to come into the room sleeps 6.5 hours per night. How tall is he? Well, that doesn't help me know how tall he is, because how many hours somebody sleeps a night and how tall they are, there could be people that don't sleep very much that are tall. There could be people that don't sleep very much that are short. There could be people that sleep a lot of hours per night that are tall. There are people that sleep a lot of hours per night that are short or average height. There is no rhyme or reason where these points are going to be for how many hours you sleep per night versus how tall you are. There's no correlation. So what am I going to use? How tall is he? Well, he's probably average height. I would go to the mean again, because I don't know anything informative to tell me anything other than that. So that's why we use the means if there is no correlation. We use the line when there is correlation. Okay, so here we do have a p-value that's significant, so we are going to use the line. Here's how I encourage you to use the line in Desmos. I encourage you to use f of x to write the equation. So f of x instead of y, -106 plus 1.05x. And then it says find the best predicted value of y if x is 133. So I'm going to plug in on the next line f of 133, and there's 33.65. So that's what I would estimate to 2 places on that value. So use the line, but plug the line into Desmos and use Desmos's function, built-in function features, to be able to make that prediction a little bit easier.